This conference will now be recorded.
All right, good afternoon. My name is Greg Wadley with CTC and Associates, and I'm the Clear Roads Administrator. We're here for the final webinar for the project entitled Using GIS to Highlight Highway Segments sensitive to De-icing Materials. This research effort is led by Mark Gallagher of SRF Consulting Group. Before I turn it over to Mark, I want to let everybody know that this webinar is being recorded and be posted on the Clear Roads website later this week for viewing by you and your colleagues at your convenience. We also ask that unless you're speaking, please remain off camera and keep your microphone on mute. However, if you have any comments or questions, please enter them into the chat box and we'll address them at the end of the presentation. I believe that's all the housekeeping items. So Mark, it's all yours.
All right. Hello, everyone. Thank you for spending some time today. This project has been going on for a while, and it has been an interesting and very informative effort. And so now, as we come down the final stretch here, I'd like to just go over very quickly what I'd like to cover in the next half hour, 40 minutes, before we get into a discussion. This really is wrapping up the project and what we did. So I'd like to start with what did we do? What was this project about, and what were the tasks within it? Then I'd like to talk about what we learned from those tasks. And from there, what did we make? The whole goal here was to create a GIS tool that was able to do some analysis. So I want to talk about that. And then lastly, what's next? We learned a lot from this effort, and I think there are some interesting directions that this work could go if folks saw it worthy of doing. So let's jump in. What did we do as part of this project? There were 4 objectives established in the initial kickoff for this project. Number 1 is establish what the current practices are in relation to de-icing chemicals to reduce environmental impact. After we find that out, we identify what is available for data. And then we look at that data and determine whether or not it's going to be useful to incorporate into a GIS tool that talks about where environmental sensitivity exists in relation to these de-icing chemicals. From there, we need to develop a model. And the geospatial model is really the heart and soul of this project. It looks at all of these data sets and creates a ranking system of the surrounding environment next to these roadways where you're applying de-icing chemicals, and starts to talk about in relative terms which are more and less sensitive. Then lastly, we incorporate that model into a piece of software and create an interactive GIS-based tool. And that will allow you to visualize where you have greater and lesser environmental sensitivity. That can then eventually inform a salt reduction or de-icing chemical reduction program. So that was the idea. That's what we set out to do as part of this project. There were 5 tasks that fed into that and helped us achieve those objectives then. Number 1 is a literature review. What have people already published about this? And we looked at academic research, we looked at industry literature, and we looked at things like best practices guides and things like that. At the same time, we did a survey to ask people, okay, how important is this to you? What are you doing to reduce? What sort of data do you collect about it? We take those things, we compile them, we analyze it. What does any of that mean? What are the approaches out there? What looks like a viable approach to creating a geospatial model based on what people do, what's important, what data is out there? And then the data sets themselves. What's in there? How do they describe things? How can we use that data? What are the limitations of it? What's the availability? All of those sorts of meta interesting bits about data sets. From there, we did a really interesting exercise with the group called creating a resource prioritization matrix. What this did, and we'll discuss it in detail a little bit more later on, is take all of those possible inputs into a geospatial model and rank them based on some attributes. From that, we were then able to narrow the field of possible inputs down into some things that were interesting, that were valuable, that were available to us that we could use to start building a model. Then lastly is that geospatial tool, the underlying analysis engine that I keep calling the model, and then the user interface and the packaging that makes it a tool that people can use. So that's how we went about this project. Those were the tasks. In terms of where we are with them, we're just about done. We're wrapping things up. There are a few things left to do with some of the documentation and the guides that we put together. I think we've got all of the revisions done. I just need a final head nod on those, and we are done with all of the tasks here, with the exception of this presentation here today. Okay, great. That's what we did. What does any of it mean? What did we learn? The literature was really interesting. We set out a few things that we wanted to get out of this effort, including how de-icing chemicals actually move from the roadway into the environment. What are the mechanisms, and how far do they travel? What is the distance from the road you need to be concerned about when you're conducting this analysis? Then document the significance of de-icing. In other words, what are the impacts that it has on the environment, and how severe are those? Then we describe the impacts themselves. How does it affect flora? How does it affect fauna? How does it affect the water itself? Then lastly, from all of those things, start to talk about the factors that influence the impact. If I put a pound of salt down in one place, does that have the same or different effect than dropping a pound of salt somewhere else? And if so, what are the factors that make it different? That's what we wanted to get out of the literature review. We learned a lot, and I'll apologize a little bit about the fuzziness of my graphic here. I just grabbed it out of the report and scaling it made it a little hinky, but hopefully you can still kind of get the point here. This was a really nifty description that our water resources people that I work with, who frankly are a lot smarter than me about this stuff, were able to really clearly show how this works. When you put this material on the roadway, and you can see the flow chart from the top, the material goes down to the left to the roadway. What happens once it's there? Well, if it's splashed, drained, if it's plowed off, but it remains liquid, it'll then drain into surface water, or it'll percolate through the soil, or it'll splash and spray onto the vegetation near the roadway. And down at the bottom, you can see how we start to talk about those impacts and summarize all of these things. So this gives us a really clear view of how this stuff can migrate and what it affects when it does. Whoops. And in terms of what happens, those impacts at the bottom, what does it mean when it affects soil? What does it mean when it affects vegetation? Well, for soils, it can actually destroy the structure and change how it drains. It can lead to decreased moisture content in the soil itself, and ultimately decreased fertility. So things just won't grow in that soil anymore. Vegetation is interesting because it can cause direct effects like leaf burn. Every now and then you'll drive down a freeway, particularly in northern Minnesota, where you get pine trees near the roadway. You can actually see where the needles are brown as a result of constantly having salt applied to them. But one of the interesting effects is that the change in salt content means that you can have an influx of non-native species that are highly salt tolerant. And that changes that roadside ecosystem, which has knock-on effects to how it affects the fauna, the animals in the area, and things like that as well. And getting to the fauna, when we talk about fish and wildlife, particularly when chlorides, the de-icing chemicals, get into the surface waters, you see direct mortality in fish, but you also see a decrease in reproductive success, which is going to affect your overall population over time. And one of the really interesting things that I hadn't thought about when we started this is the presence of salt attracts animals that are looking for salt in their diet. And as a result, you have more collisions with wildlife near the roadway. Lastly, we talk about the water itself and the groundwater. And once it gets into the groundwater, it migrates into water supplies. And that causes corrosion in pipes. Corrosion in pipes can cause increases in lead contamination of the water. It can make the water taste bad. And maybe, where it hits your pocketbook is important in that treating water with higher salinity is more expensive. So these are all very good reasons to think about how much you're applying de-icing chemicals, in this case particularly chlorides, to the roadway, because it has a whole range of effects directly on people and just on the environment adjacent. And what we took away from this, and what really informed the development of the model, is that you've got a lot of negative impacts to chlorides, which was really our focus here. Soil type, we learned, affects how chlorides are transported. Sandy soils drain differently from clay soils. As a result, they can retain that salt closer to the roadway, but have higher concentrations, or they can allow the salt to migrate away and into surface waters, into groundwater, stuff like that. Decreases the impact immediately adjacent to the roadway, but creates these groundwater effects that I was just talking about. Interestingly, trees are more effective than grasses or shrubs. Another interesting thing that informed our model development was that, in general, the highest concentration of salt are going to be about with 6 meters or so from the edge of your roadway. But we can find effects up to 30 meters away. So when we created this model, one of the things that we wanted to bear in mind is that the distance, the buffer of your analysis may vary depending upon how concerned you are about vegetation and whether or not you've got high density of vegetation near your roadway. And the last one seems obvious, but it's something that bears saying out loud, that if you're doing this in a more urbanized area that has curbs and gutters, that really limits the local impact of chlorides, but it goes somewhere. And in that somewhere is generally into a river or a body of surface water somewhere nearby. In our research, just as kind of a fun fact, I think it was the total chloride load in the Mississippi River in the Twin Cities area, about 30 or 40% of it was directly attributable to de-icing chloride application. So again, it may limit your local impact, but it all goes somewhere. So the literature review was really interesting and really informative for a lot of the work that we did. At the same time we were doing that, though, we were conducting a survey. And again, the survey had some specific goals, things that we wanted to learn. One was simply to understand how important this was to a variety of agencies. How much focus do they have on reducing or monitoring or gathering information about this? If they are doing things, we wanted to know what sort of program is out there, or what sort of tool do you use? Then lastly, we wanted to ask what kind of data was out there. What did they look at when they wanted to talk about chloride and chloride management? Because that may help us. We're going to need data to feed a GIS tool. That's what we set out to do with the survey. We sent to 64 agencies. We got 22 usable responses from 21 different states. You can see the list there. It's, to borrow a phrase from Casablanca, sort of the usual suspects. And we found some interesting things. Number one is sodium chloride was by far and away the most common chemical used for de-icing. And then most of the alternatives are things, like calcium chloride and magnesium chloride, I think it was. They're also chlorides. And as a result, we really focused this project on chloride impacts. So there are other alternatives, there are organics, things like that. What the biology and water resources folks tell me is that those have sort of a different environmental impact profile, and they're not very common. So to get the most bang for the buck, that's where we focused our effort. Also interesting is that of those who responded, 59% have some effort in place to reduce chloride use already. That tells me that this is a recognized issue. Folks understand that this has an impact and it is worth the effort to do something to mitigate that. Unfortunately, most data about environmental sensitivity comes from various printed maps that people look at when they think about how they are applying chloride. There's no real good analysis tool out there, except for one state that did actually have a scoring and mapping tool that they had put together already. And all of this tells me that people understand that this is an issue, that they think something needs to be done to do it. They are trying to gather data about it. They are thinking about it, but there isn't a great way to do this analysis yet. Then we moved into analyzing. We had our survey, we had our literature search. What does that all mean? And the way we started dealing with it was the resource prioritization matrix. And of course, the first question is, well, what is that? So what the RPM turned out to be was a list of all of these possible inputs into a model that would eventually be used by the geospatial tool. And the list of possible inputs came from consultation with the project team here and also with water resource and environmental specialists that work with me here at SRF. We called each of those things a descriptor. And descriptors then got divided into 4 categories. There's the roadway itself, which if we're talking about doing treatment for de-icing, things like that, that's going to happen on a roadway. But understanding the characteristics of that roadway can be important. The width, where it is, all of that sort of thing can be important. Future versions may even consider things like speed limit. If we start talking about spray and stuff like that, that would be a more sophisticated, more advanced version of this model. We didn't do that here, but at the very least, we need to know where the plow routes are, where are the roadways. The other types are biological, and that describes a little bit of what we call the flora and fauna. What sorts of plants? Is it mostly trees? Is it scrub? Is it agriculture? And generally, the fauna we didn't have to worry about too much specifically because animals have very wide ranges. And we know that if we've got surface water, the fauna we need to worry about is fish. If we're talking about land impacts, it's generally going to be mammals. The geologic part was interesting because that has a lot to do with just the soil type and how it drains away from the roadway. And lastly, because affecting the water itself is important, water resource descriptors. Where is the surface water in relation to the roadway? Where are things like well locations? Are there any special resource designations out there? Things like wild and scenic rivers. So that's how we divided up all of our different possible inputs, our possible descriptors. For each of those, then, we ranked them. Number 1 is availability. For this initial iteration of the model, we wanted to try to have uniform data, and that's to avoid having to have people go out and locate proprietary or localized data sets. Can we get the same data for everybody that would use this model? The next big one, of course, is utility. Does this input really matter all that much? Some really did, some were less so. And lastly, the quality. Is the data set complete? If it's available for all the states, does that mean that there's actually data for each state in there? Is it accurate? Is it up to date? Or do we have ancient data sets that are no longer relevant? So that's how we started going about deciding what would be in this model. There were 19 possible total descriptors. We ranked each of them 1 to 5. on the three criteria. And we then selected everything with a rank above 4 for possible inclusion. And with the exception of the ones with 2 X's, we included all of these. And the reason we didn't include those 2, drainage and slope, we thought would be interesting and would be a very useful thing to have. We were unable to include it mostly because it was so computationally intense. If you have data at a resolution high enough to be able to determine drainage to or away from the roadway, you had so much data if you were looking at, a large county or state level, that it just wouldn't process. We'd run machines out of memory and things like that, because it ends up being a very detailed 3D model that you're trying to create of the area. So interesting, impractical, at least for this first pass. There was a lot of discussion about, critical wildlife habitat or critical wildlife ranges too, things like endangered species. The problem with including that, it seems like a no-brainer. It seems like something you'd want. So the issue is you cannot really get point locations for things like endangered species. If it is known, it is generally not public information to prevent people from either trying to harvest or harass the animals. And when you get range data, it is so broad that it just covers the greater part of the state. And so it would affect all of the scoring in the same way. So it's essentially the same as just not having it at all. So that's why we decided, for at least this initial pass, to set those 2 aside. And now we had the basis for our model. We knew what data we were going to try and process. And that brings us to, what did we make out of all of these parts? As I mentioned, there are really 2 bits here. I don't know that the details here are super important, other than just showing the complexity of the operations in the underlying model that we created. The model is important because it is the brains. It is what is actually crunching numbers to make things work for you. And as we get into discussions about future directions, this model can be repurposed and repackaged in other things other than the geospatial tool that we created for GIS. So the first thing we did was work through with our GIS technicians and our water resource people to create this model. And you can see down the left side, there's all these blue boxes are our inputs, various operations conducted on them. It creates a series of normalized rasters, basically just pixels with values on a map. We then apply our what's called a user-weighted overlay model, that you tell the model how important all of these things are for the purposes of your analysis, and that generates a final output. That final output is all created and manipulated here in the software tool. And the software tool itself is a plugin or an add-in for ArcGIS, which of course means that you have to be reasonably proficient with ArcGIS, not an expert, but understand what's going on in order to be able to bring this in. It leverages all of the user interface elements in ArcGIS, so we didn't have to create an application from scratch to do it. When we add this in, you can see there's a tab up at the top in blue that says de-icing decision support. That brings up a toolbar, and you really just work through these icons from left to right to go through the steps to create things. And I won't go into detail here on all of the steps, but the environment settings just simply tell the tool where it's going to store its data. Input data specifies the files that you're going to be using, and there are a few mandatory pieces of data that have to go in there. Buffer processing simply creates these distance from the roadway for how far afield you're going to look. The weighted overlay analysis allows you to set all the values to define relatively speaking, what is more and less important, what will have greater and lesser weight in the analysis when it comes to ranking. And then lastly, you can create the confusingly named raster to poly button. It takes all of those pixel values you can see next to the road there and assigns them to the actual roadway segments themselves. The reason that's important is that is a tool that can be used, or an input that can be used is maybe a better way to put it, into other analysis, into other mapping, into other tools that people may want to use to talk about, here's where I have my greatest sensitivities. The other things that we created as part of this are a whole series of instructions and guides. There is a quick start guide that just tells you how to get things up and running quickly, what you ought to do to make it work. There is something called an installation guide. We ran into a number of interesting challenges getting it installed on folks' computers and getting them to use it. So we created a special guide for that. And then the whole notion of being able to weight things and customize that analysis, we created what's called the usage and scenario building guide. And what that does is tell you what the significance of changing some of these values within the tool is. Because people love to see and be shown things rather than sit and read about them, we also created a couple of video-based guides for this as well. There's a video you can watch that is the installation and getting started, that just walks you through the steps of getting things installed, getting your data loaded, setting some of the basic parameters, and clicking run on the model. And again, because there's a lot of subtlety in how you can adjust the various parameters here, we also created a companion video for scenario building. And it talks through a few of the reasons one might want to adjust these things based on what's important or less important in your particular area. So with all of that, what did we learn from all of this and what's next? We learned some really, really interesting things, and I've kind of made it a little bigger font there. It was very informative when we did development, when we tested, and when we deployed it with folks who took it and brought it into their environments and wanted to really kind of, kick the tires and see how it worked. One of the things we learned is that the model is very resource intensive, which is a geeky way of saying you need a pretty good computer to be able to run this. And we did find that at the workstation level, some users just don't have hardware that gives them a very good experience. Not enough storage, not enough memory, not enough processor, takes too long, run out of space, all of those kinds of issues. We also found that deploying this as an ArcGIS plugin actually does require a substantial amount of expertise. The user has to know what the plugin is. They have to understand what an ArcGIS environment is. They have to know how to configure things, and they need to, as we note in number 4, understand what version compatibility issues can arise. We learned the hard way that Esri, the folks that make ArcGIS, don't necessarily maintain plugin compatibility across major versions. We developed everything on the then current version of 2.9 something. I think 2.9.2 maybe was our development environment. During the course of the project, because it did go on for a couple of years, they did a major version upgrade to the 3.x series. That broke the plugin. So looking forward, need to be very cognizant of what that means and either have mechanisms to update things like plugins or find some other way to manage and distribute these things. We also ran into a number of issues all revolving around kind of local IT policies. And that can mean things like ability to install things on computers, ability to download files from given locations or given file types, network restrictions. Can you reach the data store where, for example, National Wetland Inventory is stored? All of these things came together and created a bunch of issues for users that we needed to kind of work through. And we actually built a little scripting tool that can run as well that looks for some of these possible issues and at least alerts you to their presence so that you will know who you need to talk to and kind of what you need to say when, other than, hey, this doesn't work. Now you have a place to start understanding why and how you might change that. The other thing we learned when it was all said and done, and perhaps this is a conceptual thing that needs to be looked at, the overall sensitivity score, which in the end is essentially high, medium, low. It's 1, 2, or 3. It lacks a certain context. We're able to tell you in relative terms which areas, based on their physical characteristics, are going to be more or less sensitive. But again, in practical terms, what does that mean? What is the difference between low, medium, and high? How high is high? How low is low? Those kinds of questions weren't something we could really answer as part of this project. And maybe more importantly, we had some discussions like this with the project team. Great, even if I understand that, how does that translate into a program? What does it mean in terms of de-icing treatment? What do I change? How do I need to make an alteration to my practices in order to affect that kind of ultimate application and whether or not I'm affecting things in sensitive areas? So we learned some really interesting stuff, both on the technical side and more on the theoretical side when approaching something like this that maybe was just not obvious at all when we started. So where do we go from here? What are the next steps? Well, one thing that may be valuable to do is simply look at moving all of this to a platform that doesn't require as much local interaction. ArcGIS seemed like the obvious path forward when we started. When we actually deployed it, it doesn't work as smoothly as we had hoped for a whole variety of reasons. The good news there is that the underlying model, the geospatial engine, can be repurposed for other things. So in a way, the hard part is done. We have an engine that will ingest data, that will generate outputs. The question is, what's the best way to get that in front of people? How do you hang an interface in front of that? The other piece that we looked at is, because folks had issues retrieving data in some cases, does it make sense to have a curated repository where, for the purposes of this analysis, there is a mechanism to make sure that that is consistent, that is uniform, and that is up to date, and people only get things from one location? And if we move to a platform that doesn't require a lot of local installation, can those things just be integrated together? The user interface, again, we leveraged ArcGIS. To use it, you have to know how to use ArcGIS, and we simplified that as much as possible, but we work within the constraints of that application, and there's probably room to simplify that and make it a more straightforward and make those inputs in terms of what they do more obvious. There's a lot of entering numbers in the ArcGIS interface that could maybe be simplified by creating more, knob twiddling sort of graphical interfaces. And the last 2 points kind of pivot off that last point from the previous slide. There seems to be a need for some more research between when you do this analysis and you generate some relative score, some relative evaluation. How does that translate into what the environmental impacts are? What is that relationship? And that was not something, again, we could really address as part of this project, but it seems like an important question. And then the last piece also kind of talks about the same sort of things. When you know something is more or less sensitive, what do you do about that? What are the suggestions? What is the basis for a reduction program, particularly one that is tailored geographically to address the most sensitive areas in the most intensive way? So that really kind of wraps up the presentation part of this. We talked a little bit about doing like a demo thing where we could show you the tool, but because it is so computationally intensive, you can click on a few things and set it up and click run, and 45 minutes later, it has your raster ready for you. So it wasn't really practical for that. But if folks take a look at those instructional videos, we do show the interface in there, how it works, what the outputs look like, and things like that. So that may actually be a better way for those who are casually interested in seeing what it's look like to see what is out there. With that, I will stop talking and open myself up for questions.
Thank you very much, Mark. I really appreciate that. Just to let everybody know that currently all these deliverables, including the videos and the installation guides and such, are right now they're available on the members page under research project documents. As soon as we sort of finalize the final report, which will be within this week or maybe early next week, get it posted on the on the project page, and we'll migrate those other deliverables to the project page, and they'll be available. I mean, they're available to you now, but they'll be a little bit more obvious and available to the rest of the public at that point in time as well. So anyway, all right. I don't see anything in the chat box currently. There we go. Craig's got his hand up. Go ahead, Craig.
Hey, Mark, Craig here from Iowa.
Yeah, hey, Craig.
Having listened to some of your recommendations, in a quick summary, do you think that there's value in having some sort of a follow-on project with this? And kind of, if there is, can you kind of summarize that again, what you think we as a TAC should potentially look at?
Sure. And I mean, I'll set my consultant hat aside here for a second and put myself on the side of somebody who is a program manager who is interested in doing this stuff. I would want something that is very easy for me to access, and something I'm not going to touch very often necessarily, maybe at the beginning of each season or at the end of each season. So I would want something I don't need to install or maintain myself. And I would want something that is relatively straightforward to just have a scenario or two in there. What we have kind of rattled around over here at SRF, if we were in that shoe, is we'd want something like an ARC Online application that would just move all of this stuff out into something that is accessible via a web browser, and something that somebody else maintains. Doing that, I think, would, number one, for this group, make it a lot easier to access and use. Number two is, if you so chose, I think you could make this tool available to a lot more jurisdictions, down at the muni level and things like that, where you could just say, hey folks, we have this tool available. Here's the link. Here's what you need to do to create an account. So the steps to get there would be to redesign the user interface. What does it need to look like? Develop an online version of that so that it could be installed as like an ARC Online application. Resolve the hosting and processing side of it so that it lives somewhere out in the cloud and is accessible, and somebody is responsible for maintaining that. And then organize all of the data that needs to go into it, because you don't want individual users then who are accessing this remote application to be messing with the backside data. So that's what I see as sort of the 5 bits that would need to happen to make this a more accessible and I think easier to use application. You see another
Okay, very
hand?
good. Thank you, Mark.
And Craig, just so you know, and this is not at all a conflict of interest with Mark Gallagher being on the phone here, but just so that you're aware, Joe T is putting forth that very project idea through the research development process, and we'll discuss it at our meeting next month. And Joe, if you want to say anything about it, feel free.
Sure thing. First, I wanted to thank Mark and the whole team at SRF. It was a journey getting to this point, and their commitment from cradle to almost grave here has been very commendable, and also to the other folks on the Clear Roads group who were part of it. Initially, and it's a good, I guess, segue, because we were talking about making it an easy to access, and that was one of the original intents of this project, so that it would be an easy to use tool. And I myself struggled with it with my old Dell laptop trying to get things to run, um, the old college try prevailed, and actually I was using the tool this morning to run a couple of different scenarios. And one of the things I did want to kind of park on and emphasize is the weighting of the tool, because you could weight things differently. And I just ran it very simply with water and soil, and did one at a 50% weighting versus a 30 to 70% weighting. And they returned. It was pretty interesting on one beat. It returned a very different result, and on another one that was more rock and hard and um, rocky type soil bedrock was pretty much just relatively the same. So the weighting of the tool was something, and just kind of circling back on our amendment to this project, that was one of the things, was the usage guide, and coming up with something that is a kind of a standard for what we should do with this. But all in all, a great product, and that's about all I have to say about it, unless anybody has any questions for me.
All right, thanks, Joe. Okay, does anybody else have any questions for Mark or Joe on the project subcommittee?
I'll just add I hadn't heard that knob twiddling before, so I'm gonna use that one, Mark. That's a good way to describe how the scenario building and the overlay analysis work.
Yeah. And part of the challenge here is that there are a lot of knobs, and some of the knobs have knobs, and coming up with a better interface that presents that so you don't have to have quite as in-depth an understanding of what's going on, I think would go a long way for folks.
Right. Seeing no further questions, well, let me give it one more try here. If anybody has, you don't have to put it in the chat box since we're done. So if you just want to speak up, please go ahead and do so. Okay. Well, thank you very much again to Mark Gallagher and the rest of the SRF team. I know he had a lot of folks over there working on this. Rick Lovell was another one of the technical leads in this project, and then of course the project subcommittee from Clear Roads. A lot of work was done there, and really appreciate it. And like I said, we'll hear some more about this from Joe next month in Annapolis, and we'll just go from there. But I will have this recording posted on the Clear Roads website, as well as I will get the tool and the other guides and such and videos uploaded onto the project page here very soon in the final report. So yeah, look for that, and I will notify you when all that stuff is uploaded. All right, well, have a great rest of your Wednesday, everybody, and we'll talk to you soon.
Thanks everyone.
Great.
Thanks, Mark.
Thanks all.